Saxon's Calculus, Lesson 21, is about inverse trigonometric functions and trigonometric equations, and it begins on page 116. So we remember that if we have inverse, it's the same as asking for arc. And the way we're going to know it's inverse is we have a -1. So sine -1 of theta is the inverse sine of theta, and that means it's asking for the degree. And it also can come from arc sine of theta, and that would mean the same thing. What is the degree of whatever they're providing? Now they go through some explanation about memorized sections of the curve for sine and tangent and cosine, and I feel like we can find these answers without having to memorize more things. And if it is necessary, I also know that I can look it up if I so need extra information that I can't get from the way I find my answers. And there's some extra information written here in my book from another teacher that in your 4 quadrants, we have memorized all students take calculus to remind us that all of the words sine, cosine, and tangent are positive in quadrant 1. Only sine from students is positive in quadrant 2. Tangent is the only positive in all students take, and then calculus would mean cosine, and of course I'm implying they're inverses, secant, cosecant, cotangent. Those words, the same rules apply, would be positive here in this quadrant. So she said sine and tangent, it's part of the memorized asymptotes, that sine and tangent are applying correctly in 1 or 4, and then cosine should be graphing in 1 or 2. Again, I don't like memorizing extra stuff if I don't have to. So let's jump to example 1. Evaluate the inverse sine for radical 2 over 2. So what I know is that I'm looking for a degree and I'm graphing a positive for sine. I'm going to stick to the first quadrant. That's where she was trying to say which one is closer. I'm either going to graph it in the first quadrant or the fourth quadrant because they're the ones attached to the 0, the closest ones. For cosine, I can't be graphing here because the information they're giving me tends to apply over here in these. Okay, but we'll get there. So the other problem I have is that I recognize that root 2 over 2 has been simplified. So it actually started as 1 over root 2, and that's what I want to deal with in graphing. So now sine is opposite over hypotenuse. So my opposite needs to be 1. My hypotenuse needs to be root 2. Okay, that should be ringing bells in my head that this other side is 1 because it's memorized 1, 1, root 2. So what does that make that degree? 45 degrees. Now the original, so they say most of the time in calculus they're going to want the answers in radian. However, they didn't specify what they wanted it in, so I would say 45 degrees is fine. I look at example 2, and they wrote that answer in degrees, so they're not even sticking with they typically write things in radian. Doesn't really matter. Either way you write it, and of course you're going to get to 45 degrees first. But if you needed to convert it, 45 over 1 times, you want the pi, and you want to lose the degrees at 180. So 45 goes into 184 times. So that means it's pi over 4 in its radian format. Now, example 2. Evaluate inverse cosine for negative root 3 over 2. So my cosine would be negative, not in all students take care, and it can't be in calculus, so because those would be the positives. So the closest one I have is in quadrant 2. Okay, So now, is this one that I have fixed? Nope, because these aren't the same numbers. So cosine is ca, adjacent over hypotenuse. So I know my hypotenuse is 2, my adjacent is the negative root 3, and that makes this memorized one at 1. And what is the degree opposite the 1 in this case? Well, 30 degrees. However, it's in quadrant 2, so 30 degrees may be in here, but the answer is from the 0. So that's shy of 30 degrees, or 180 degrees by 30, which means 180 minus 30 is 150 degrees. And again, we could convert it to radian, but there's no point doing extra work if we don't have to. Now, part B, trigonometric equations, says, given that secant x equals -2, find all the answers between, and it says x is greater than or equal to 0 and less than 360. So my boundaries are between 0 and 360, one wrapping around in the grid, not multiple wrappings around. So secant is the opposite of the word cosine. So that means ca, adjacent over hypotenuse. So this is hypotenuse over adjacent, implying over a 1. And I know that my hypotenuse can't be the negative, so I'm going to shift the negative down here to the 1. It still keeps it overall at -2. And now I'm ready to graph. Where does that fall? So it's negative, and it's based on cosine, so it can't be positive in all, and it can't be positive where we had all students take calculus for that cosine. So we're going to graph it here and here. So my hypotenuses are 2. My adjacent is -1 in both. I just only have to write it once. And then is that a memorized triangle? Yes. So the other one here is root 3, and here it's -root 3. So what is the degree opposite that? 60. So then in my actual answer, 0 up to here, I'm shy of the 180 by 60. So that gives me 120 degrees. And then in this quadrant, it's 60 past the 180. So that is 240 degrees. And I'm fit between the boundaries. I've got the two answers that we're looking for. Now, example 4. Sine squared x equals 1. And again, the boundaries are between 0 and, this time, 2 pi. Now I know for sure my answers need to be in radian format, definitely not in degree format. Now, if you recall from trig, we want to avoid canceling things out. So if I just tried to square root both sides, I would get my positive and negative square root of 1 is 1, and that might give me the two answers, but it is always, always best to factor rather than do something else to for sure avoid losing answer sets. So we're going to split sine squared into sine x and sine x. 1 splits to 1 and 1. And, sorry, let me fix this. I did it here and made it equal to 0, but I need to set this equal to 0 before I can factor it. So that's going to -1 when I move it over and make it equal to 0. So now I know I have no middle term. One sign has to be positive, one sign has to be negative, and I always double check. Positive times negative is negative. Yes, this is the correct factoring. So here, sine of x equals -1, and here, sine of x equals 1. Now, in this case, if I had square rooted, I would have gotten that same positive and negative square root of 1, but I'm following the best practice in always factoring to avoid losing, even though in this case it doesn't. So now, because I have positive and negative forms, I'm landing in all 4 quadrants. 2 of them are the positive, all and students, and then these 2 are the negatives. So sine is opposite over hypotenuse, the so, and this implies 1 over 1 or -1 over 1. The hypotenuse, of course, can't be the negative, but that's okay, it's written correctly. So the opposite is 1, 1, or here, -1, -1. The hypotenuse is 1, 1, 1, and 1. Now, what I realize is that my side and my hypotenuse are identical, so that tells me the third side can't exist. So these are actually zeros. And so if I am not traveling over at all in either direction, I'm traveling up for these two. I'm on this line, which means that's the 90 degrees. And here I'm not traveling over, I'm traveling down. So what line is that? 270 degrees. But they don't want my answer in degrees, they want it in radians. So I either convert each of them, or if you have the radian version memorized for these, you can just jump straight to it. Now, we know that 0 and 180 are memorized easily at 0 radians and pi radians, so this would be halfway. So I know that it's going to be pi over 2 for the 90 degrees. That one I basically have memorized. And then the 270 actually is 3 pi over 2. Again, I might have it memorized, but if I don't, then do either manually or on your calculator. I want the 180, and the pi is the conversion fact. The zeros can cross off. And what goes into 27 and 18? 9 does. So 9 goes in here, leaving 3. 9 goes in here, leaving 2. Either way, I'm getting those two radian answers. Now, example 5. Tangent squared x equals 3. I wasn't sure if we had space to do it there or not. I don't feel like I'm going to risk it, so let's do our tangent squared x equals 3, bounding between 0 and 360 degrees. So I know I want my answers in degrees. We're going to move the 3 over. Tangent squared x minus 3 equals 0, so that we can then attempt to factor. And that goes to tangent x. These are not instinctively identical. If I used 3 and 1, it does make 3, but they're not the same. Is there a number I can fill in that is identical, and I use another clue that it should be based on things I'm used to seeing, like the parts of a 45-45-90 or a 30-60-90? Oh, how about root 3? Because root 3 times root 3 equals 3. I have no sign in the middle, so 1 should be positive, 1 should be negative. That kills the middle term, and then positive times negative is negative. Oh, good, that is the correct factoring. So now tangent of x equals, in this case, negative root 3, and in this one, positive root 3. And I'm going to write them as fractions because tangent stands for TOA, opposite over adjacent. I'm going to, again, graph in all 4 quadrants, 2 for the positive, 2 for the negative. And then my opposite is negative root 3 in these, and positive root 3 in these. And the adjacent is 1. Here, technically, it's -1. Yes, and that's okay, because if I put negative over negative together, this is one of the positive forms, and this one is the other positive form. This one would have 1 at a negative and 1 at a negative, so these two are the negative form. I knew they fit in there, but I didn't want that to kind of throw you, so I wanted to make sure. So now, what's our hypotenuse for each of these? 2. So we are opposite the root 3. That means each answer is 60. Thankfully, they want them in degrees. So for this quadrant, that's 60 degrees. Here, it's 180, 60 shy of 180, so 120. In this quadrant, it's 180 plus 60 more, which we already said was our 240. And then here, we are shy of hitting the 360 by 60, so that's 300 degrees. Example 6, cosine squared plus 2 sine minus 2 equals 0, and bounded between 0 and 360. So good, my answers are in degrees. I didn't write the x's here, I know they're there, but we're going to attempt to factor this. So we have cosine and cosine. And then I have 2. So the only way to get 2 is 2 and 1. But I need a 2 in the middle. So if I add 2 and 1, I get a 3. If I subtract, I get a 1. That's problematic. Oh, mercy, I can't do this anyway because this is cosine squared and this is sine. We're not ready to factor at all. These aren't the same words. I can't proceed until they are the same words. So cosine squared is going to have to change into its sine format so I can factor with sine. So cosine squared is 1 minus sine squared. If you remember, that comes from sine squared plus cosine squared equals 1. All right, plus 2 sine minus 2 equals 0. So now I have negative sine squared plus 2 sine, and I know I ignored that for a second. I just wrote that one down and wrote that one down. This positive 1 minus 2, I'm now going to put together and make negative 1 equals 0. But I can't factor with a negative with my sine squared, so I change everybody's sign. This one goes to positive, this one goes to negative, this one goes to positive. Now let's see if we can factor. Sine squared goes to sine and sine. 1 goes to 1 and 1. And 1 plus 1 would give me a 2. This is negative, so if they're both negative, that would add to negative 2. Negative times negative is positive. Yes, correct factoring. Great. So we solve sine equals positive 1 here, and sine equals, the same positive 1 there, because they're identical, so I don't have to do it twice. Implied over 1, sine is so, opposite over hypotenuse. Which quadrants will sine be positive? All and students. So my opposites are 1, my hypotenuses are 1. Ooh, that means, again, I'm not traveling over, so I don't go over, I go up. Well, that is the 90 degrees, as we said. So 90 degrees answers the question. Example 7, yes. So solve 2 sine squared equals 3 plus 3 cosine. Again, I left those thetas off, but that's okay. Between 0 and 360. So I know I'm in degrees, that's good. Again, I see, sine squared and a cosine, so I'm going to have to change the sine squared version. So this is 2, 1 minus cosine squared equals 3 plus 3 cosine. Distribute 2 minus 2 cosine squared. And since I know I need to factor and it needs to equal 0, I'm going to go ahead and write minus 3 and move it, and minus 3 cosine and move it equals 0. So now I'm going to put like terms together and keep everything in order. So negative 2 cosine squared minus 3 cosine. 2 minus 3 is negative 1 equals 0. I can try, well, I'm definitely going to change everybody's signs. Positive, positive, positive. And I can divide everything by 2 and try to work with fractions, or I can attempt to do the more difficult factoring, which changes that to 2 cosine and cosine. This means that whatever I put here multiplies with 2 before it does the addition and creates a 3. The only way to get 1 is 1 and 1, but this makes 2 and this makes 1. And 2 and 1 will make a 3, so that is definitely possible. 2 is the larger, so the sign in the middle is positive, so this larger needs to be positive. And then how do I go from 2 to 3? I add one more. Positive times positive is positive. That is correct factoring. So now here when I solve, we get cosine of, I'll put my theta back, equals negative 1 dividing by the 2. And here cosine of theta equals negative 1 when I solve it out. Now we graph. Cosine ca, adjacent over hypotenuse. This is negative, so it won't be in all or calculus, so it will be in these two for its negative format. So the adjacent is negative 1, the hypotenuse is 2. That makes this root 3 and negative root 3. And think I can graph. No, because this one's also negative. Okay, I was hoping I wouldn't have to draw another graph, but that's all right. So because it's still negative, it's still landing in these two quadrants. So then implied over 1, the adjacent is still the -1. The hypotenuse is now 1. That's matching. So these are zeros. So I'm moving over, but not up or down. So that's keeping me at 180 degrees. I just went ahead and answered that one. And now back up here, the opposite of root 3 is 60. We are shy of 180 by 60, so that's 120. And here, 180 plus 60 more is the 240 degrees. And they always write them in order. Oh, no, they didn't, because here they did 180, 120, 240, as long as you have the 3 answers. But typically they will write it at 120, 180, 240 and put them in order. It doesn't really matter critically which way you do it.